All right. Good morning, folks. Thanks for joining us for another Oracle Database in Memory office hours. I'm Maria Colgan. Joining us and actually hosting the meeting today is Andy Rivenes. Right now, everybody's lines are muted. If you've got a question, feel free to put it in the chat while Andy's presenting. And later on, once we're done with the initial introductions of the material and the demos, then we can open up those lines for Q&A. I'll also interrupt Andy as we go through and ask him any questions that appear in the chat as we get going. But without further ado, Andy, I'm going to hand it over to you.
Okay, thanks, Maria. So today I thought we'd, actually this is our first, or what's our second Ask Tom office hours of the year, but the first one that we've done, the first one was a review, and now we'll kind of jump into some more topics. And I thought it'd be kind of fun to do JSON. And so I thought we would talk about how JSON works in Oracle Database and also how we can leverage it with database and memory to actually give you the ability to run analytics on JSON data, which is kind of an interesting proposition, I think, and can be very valuable for a lot of customers. So with that, I think we'll go ahead and get started. We have our safe harbor statement, but we're not going to talk about anything particularly new. As actually JSON started with support in Oracle Database. Well, we'll get to that. I have in 12.1 and then database and memory in 12.2. As a kind of a quick review, though, just database and memory, all about real-time analytics, fully integrated into Oracle Database, which again we'll kind of talk about today because JSON is part of Oracle Database, and database and memory can pretty seamlessly access that JSON data and accelerate queries on it. And of course, trivial to implement. We've talked about this before. Just setting, allocating memory and altering tables in memory, which we'll actually get to do today as well. And it's really all about columnar formatted storage and making that access to Oracle data in columnar format with in-memory is what I like to call an enabler, and making queries 10x faster, orders of magnitude faster, analytic queries. And so we're not going to speed up inserts, updates, and deletes. We still have the row store, and all of the data is persistent in the row store just like it is without database and memory. And then with database and memory in this new columnar format in an in-memory column store, which we've gone over. And I should just remind everyone that on the Ask Tom website where you signed in, when you click to join, down below we have all of our previous sessions there. And so if you want to go back and look at some of the things we've talked about, which one of them was how do you allocate the column store, how do you set that up in database memory? How do you populate? You can go back and look at those previous Ask Tom sessions to get a feel for how we do that if you're not familiar with that. And I think to close that out is that column store, we can populate. You get to pick and choose the objects you want to populate, and it can give some phenomenal performance improvements. It's a pure in-memory format, and the optimizer decides, do we choose the row store or do we choose the column store? And so I think I just wanted to just very quickly review that for any folks that might not have been, if you're new to database and memory or new to our Ask Tom sessions, so that you can feel comfortable with how database and memory works. And with that, what I wanted to do is, I'm just going to do a few slides, and then we're going to jump in and do some demos like we typically like to do that with SQL Plus and show you how it works as opposed to just doing slidewares. But I did want to kind of preface, and I thought I'd put some architectural diagrams together, which I thought would make it a little easier to visualize how JSON works in Oracle Database. When we jump into this with SQL Plus, it's a little harder to visualize that. So I thought this might be a good balance. So JSON in Oracle Database, we introduced support for JSON directly in Oracle Database in 12.102, actually as a JSON. We mark it with a check constraint to tell Oracle Database that you have well-formed JSON. And I have an example here of just a JSON document. It's actually just one of them. We'll look at it in one of my demo tables. But I like to say it's a less formal markup mechanism than, say, XML. But it's really just a markup language. and very common in NoSQL databases. So, and very popular because it relaxes the requirements to have schemas and have everything set up in schemas and have it very, what I think some developers would call too rigid an environment. So it can be very flexible, it can be added and subtracted. You can make it the documents how you want them to be, and it makes it very simple to develop applications and move data around in Oracle or in other environments as well. Hi, everybody. I wanted to clarify a couple of things that we had in the Ask Tom session. What I had talked about was the ability to create an isJSON check constraint and have that create an OSON hidden virtual column under the covers. And while that's true, what I wanted to clarify was that I didn't properly, I don't think, when I'm looking back at the video, explain that that's a 12.2 feature that does require the max string size to be extended. So I added that in two of the slides that I'm going to show coming up here. And I put that in here, and the max string size extended. And then we'll then talk about the actual OSON hidden virtual column, and I tried to highlight that there as well. So I didn't want to mislead anybody. I didn't think I explained it very well. I did pick a couple of sections out of the later on in the video when we did discuss that, and I did clarify that. And I added those in a couple of places where you see a clarification note. So it all works the way we talked about, but it does require at least 12.2, and it also does require that you have the max string size set to extended. And that's the part that I wasn't clear on during the discussion. And so I wanted to make sure that that was clarified. Thanks, and enjoy the rest of the Ask Tom session. So JSON in Oracle database can be stored as a blob, a varchar, or a clob. The blob format uses or requires a format JSON, so you got to tell the database that it's JSON. There are a bunch of different functions available with the JSON data, or the ability to query that JSON data in SQL. There's actually a dedicated document in the DocSet JSON Developers Guide, which goes through all of this information, and actually also, when we talk about database in memory, also details some of the requirements for database in memory to allow you to populate JSON data in the column store. So the JSON Developers Guide is kind of a great go-to for information about JSON in Oracle database and database in memory. Funny enough, we don't really mention much in the in-memory guide about JSON. We basically refer you to the JSON Developers Guide. So you're going to wind up there either way, and so that's where you can find this kind of information. You can index JSON documents or data, and dot notation's available. Interesting, we'll talk a little bit more about this because I thought this was kind of interesting. You add a check constraint to the JSON data, and that tells Oracle that the data is well-formed JSON data. So it allows Oracle, actually behind the scenes, I'll show you, it creates an OSON version of Oracle JSON or of JSON. And what we basically, Oracle, it's a special binary format that we're able to query on. And so it makes that data actually just more efficient, allows us to more quickly access that JSON data and allow you to do searching and retrieving of information. And then when you do bring JSON data back, it's always brought back as a character, varchar2 format. So it's all character, no matter how you stored it, whether it was in a blob, a clob, or varchar2. And with that, I tried to, we had originally, when we did database in memory in 12.2, we created some pictures of how JSON formats were used in or populated into the column store. So I tried to take that apart a little bit and show you how it's stored in Oracle database. And so this is my attempt at showing JSON in Oracle database without database in memory, just like basically 12.102, you could first use JSON. And so what this basically shows you is a JSON column, so a column value you've loaded a JSON document into. And then if you've added the JSON, is JSON check constraint, what we actually do is behind the scenes, we create a hidden virtual column that's OSON format. And you can see this in the database. And so even though it's a hidden virtual column, it's still exposed if you query the right view. But it's a 12.2 feature. So I tend to use the latest and greatest. But this all works with 12.2 and above. Yeah, as long as that's set. Max string size extended, right? Try that. I cheated and created a script so I wouldn't forget to show everything I was interested in. Initially, I had loaded up a table called retail, and it just has one column in it. Just called it C. It's a JSON type. And so what I can do is I was just going to, it's easier to cut and paste than it is to type for me anyways. So what I wanted to do is show just the one. Now this isn't formatted. You can cut and paste this into a formatter in HTML or in one of the. There's many on the web to do that. But basically, this is the same JSON that I had here. So that's nicely formatted, and that's not. But the point is that this table has a whole bunch of these JSON documents in it. I could have typed that, but I didn't. It has 360,000 of these rows of JSON. And so that's what we're working with. And then what I wanted to show was this one I will type. That because we put the check constraint on this table, retail, what Oracle really did behind the scenes, and let me move this over so you can see this, is it actually created a hidden virtual column. Notice the name has OSON right in it. And it's 32K. It's raw, but it's a hidden virtual column. So it does that so that when you run SQL against JSON, it can be much more efficient. It knows that it's JSON, and that leads us a little bit into our database and memory discussion, which is why I made a big deal about it. So, but you don't have to have database and memory to make use of JSON in Oracle database. However, if you do, it'll be a lot faster, and hopefully we can show that.
So Andy, there's nothing I need to do in terms of how I set up my database or anything in order to get the OSON other than adding the constraint?
Yeah, as long as that's set. Max string size extended, right? And I had to clarify some of this because it wasn't well understood how OSON was used in Oracle database outside of database and memory. So, so anyways, I do have that, and I will try to remember to bring up, I'll leave the teaser right now, the page with database and memory itself. But that doesn't require anything special in Oracle database for that. And if you want to go larger character set, then obviously you have to extend the database or tell the database that you're going to use 32K. And we actually did a blog post on that as well, which I'll show when we get to that conversation. But I think for now, that was everything.
Okay, but you can hear me. All right, great. So I'm guessing Andy's going to reconnect. And so I'm going to ask you all to just bear with me. In the meantime, I'll talk a little bit about why I think it's so cool to use JSON in the in-memory column store. Obviously, as we do new application development, one of the things that a lot of the developers I'm working with, both here at Oracle and with other companies, they're looking to use JSON because of the flexibility it gives them in that application, initial application design, because of course they've got complete flexibility of the schema that we don't have to go through rigorous schema design, because as long as we're just ingesting JSON documents into the Oracle database, then the schema is technically defined within the JSON documents, and not all JSON documents need to have all elements of the schema. So if new requirements or attributes come in, they can simply be added to newer versions or newer documents that get added to the database. Now, because your schema is constantly evolving in such a manner, Oracle provides a JSON data guide, which will allow you to actually see what's inside those JSON documents that are getting stored in the Oracle database. And what it'll show you is actually a list of all of the attributes that have been stored and the corresponding data type for those attributes, so that you can keep track of the schema, so to speak, within those JSON documents. Okay. I was just chatting about the use of the data guide so that you can actually tell what's going on inside in your JSON documents. One of the other neat things that we have with the Oracle database, and Andy I think is going to show you some of this as when his demo is back up and running, is that you can very easily navigate through a JSON document stored inside the Oracle database using the kind of standard dot notation that we have in SQL. So typically I would do schema name dot table name dot column in order to extract a particular column from a table. We can do a very similar thing with JSON and navigate through the different attributes or elements in a JSON document and only pick out the elements that we need, which is quite nice. You can also pretty print the JSON document. So not only can you return JSON documents in a JSON format, you can also actually return any relational data within the Oracle database as a JSON document, and you can even get it to pretty print that JSON document if you wish, using our JSON value functions that Andy mentioned earlier on, which is another neat feature. And if you're all the way up to Oracle 19c, we also have another neat feature which allows us to actually update the element values within JSON documents without having to store a brand new copy of the JSON document. Traditionally, if you had to, update an element of the JSON document, we'd simply insert a new version of the document, delete the old one. Now we're able to actually do the update in place and just change the attribute, one or more attribute values within a JSON document, or for all of the JSON documents that are stored in a table, which is pretty cool. As you can imagine, you can insert JSON into the Oracle database using all of the standard techniques. So you can do simple insert statement, just as Andy was showing there just before he disappeared. But you can also bulk load JSON into the Oracle database using all of our standard techniques. You can load it from external tables. You can do it also from any of our client drivers, basically can handle JSON and put it into the Oracle database, which is really nice, making it very slick. Gerald Wenzel and I have a little demo where we do a coffee shop application. If you're coming to Open World this year, you'll get an opportunity to see that session, hopefully. And what you'll see us do is a JSON-based application, so a Java application that ingests JSON documents into the Oracle Autonomous Transaction Processing Database. And we can do transaction processing and analytics on those JSON documents all at the same time, which is pretty cool. Because with that dot notation, we're able to, of course, join the JSON, elements of the JSON documents with relational data, which is another nice thing. So you can do joins, group bys, aggregations over the values within JSON documents. So it's actually a pretty slick way to quickly implement a new application and also begin to run analytics or any kind of queries or SQL on that.
Well, all right. I don't want to make you do a song and dance, so we'll just move on. And unfortunately, I'll have to show it to you as the actual screen print, because my VirtualBox does not want to finish coming up. So what I was going to show, see, am I sharing my screen yet?
Not yet, sir.
Let's do this. How disappointing when you spend all that time getting things set up and then it doesn't quite work. So what I was going to show everyone, we were just talking about, can you see that? Is that okay?
Yes, sir. We can. Yeah, we see you now.
So the retail table that I had created for the demo, I'd shown you that I had the C character, or the C column, which had our JSON in it, and then I had created a check constraint, an isJSON check constraint, and that had created an IME or an OSON column as well. And what I wanted to show was creating just a table and actually showing you that initially I just created a table with the C column, varchar2 of 4,000. And then once I added the check constraint here, that is what actually produced that column, that hidden virtual column. So that was what I was headed towards before everything crashed. So hopefully you get the flavor for that. The great thing about this is so simple that anybody can try this. Just download VirtualBox and you can try this on your own. And then let's look back to the presentation, talk a little bit about how that works with database and memory, now that we've kind of described how that works in Oracle database without database and memory. So maybe see if we can make this a little bit bigger. And move on to JSON with database and memory. So in 12.2, we added the ability to populate JSON data in the column store. So now, not only could you do queries on JSON data in Oracle database, you could get phenomenally better performance by populating that data into the column store. And so required 12.2, and it also, now we get to this max string size we talked about a little bit earlier. And for database and memory, it does have to be set to extended, and that allows 32K varchar2 columns, and that goes since we implement the JSON support through in-memory expressions, which we talked about in a previous session, we require that this be set up prior to populating the data in the column store. In addition to that, we have another parameter, in-memory expressions usage, and this is all essentially in-memory expressions requirements, since that's how we're implementing this under the covers. Either static only or enabled for in-memory expressions usage, and then in-memory virtual columns we set to enable. So those are the setup things that you have to do for database and memory to enable the use of both actually in-memory expressions and, in our case, using JSON with database and memory. In addition to that, we've already talked about the isJSON check constraint and what JSON, or what we call OSON, really is, which is just a binary format to make it more efficient for Oracle database. So my second attempt at architecture diagrams was I took basically the previous diagram and tried to add in how it works with database and memory. So we still have our JSON column in our demonstration. It's our C. I probably could have been more imaginative in the name of it, but I just labeled it, the column as C. We have our isJSON check constraint, so we've created OSON. That's the little arrow there. It's trying to show a relationship between the two. And then we can then populate that data into the column store. It's obviously still available in Oracle database in row format. You can access that column, but it's actually much faster to populate that in the column store, and that's what my little column here that's a different color, whoops, I want to move it around, but a different color, there we go. And that actually gets populated in the column store in the OSON version of it. And then it's also possible, as Maria was talking about, trying to cover for my machine's failure, that there are other functions available with JSON that then can actually also be populated in the column store. So, for instance, JSON value, which is typically the example we use because it allows you to take a part of the JSON document and perhaps do analytics on that, which then might lead you to accessing the rest or other parts of the JSON document, but getting that subset of data with SQL queries very, very quickly, and then maybe accessing the other parts of a JSON document so that you don't have to actually go through the whole JSON document in order to find the values you're interested in. And so that's kind of the analytic value of having JSON populated in the column store, and the ability to, of course, then to create these different functions. And it's phenomenally faster. And so fortunately, I'm not going to make an attempt to do this live, which I apologize for, but we will go through, and I put timings in here. So let's take a look at the text version of our SQL Plus session, if you will. So I kind of showed you before the 360,000 rows from the retail table. To add a JSON value function, I have a statement here. We're going to alter our retail table. We're going to add tax amount as a JSON value, and we're going to root around in dot notation, which Maria also mentioned, to get us the tax amount in our JSON document. And we're only going to populate just that value in the column store, in addition to the fact that we're going to populate the entire table, so the C document will also come along with it. So both will be there, in essence, populated in the column store. And so, actually, where did I have the alter? Somewhere in here, I populated the column store, but I might not have included it in this. But obviously, when you got to populate it in the column store, you have to get it there. And if you add, if you make changes to the table, just like you would if you had a normal table, if you added a column, if you created an in-memory expression, or if you do what I did and created or added this JSON value, which is essentially adding another in-memory expression, you have to populate the table or repopulate the table. And so I unfortunately didn't include that in this, but suffice it to say, you can go back and just do either an alter table, essentially an alter table retail in memory, and maybe set a priority so that it automatically populates. We have to repopulate that to rematerialize any additions that you make to the table, in this case, another in-memory expression in essence. And so what I had, though, is a query from our retail table, and this is basically prior to populating it in the column store. And we're going to root around and look for, notice the table function, JSON table, and we're going to go through and look for some values in the JSON in that column, notice O.C, and we have retail with an O alias to it. So we're going to go through the C column, if you will, and we're going to look for some certain parts of each of the documents. And that's, we're going to come back with 1.3 million rows, if you will, from our table, and it takes 6.5 seconds. It runs in 6.5 seconds, not leveraging database and memory, just going through the JSON column in the database. So that was kind of our control, if you will. And we see that I included the execution plan, since we always tend to do that, and we're doing a table access full against the retail table. Notice it doesn't say full in memory. And we have our other information, some statistics, but again, our IM statistics basically say we didn't access that in the column store. So then I populated the data in the column store. So here's the section that I was talking about. And notice that I checked the population. This is actually just from one of our hands-on labs that essentially just selects $IM segments. And notice that the retail table is populated in the column store. Bytes not populated is 0. And so now I was going to query that same query, but I'm going to tell it don't use IME. So I'm going to cheat with an underscore flag that you can ignore, but it was easier to do this than so I could do it all in one step. And so I queried that table in the column store, but we're not leveraging OSON at this point. We're just actually leveraging the C column that's been populated as varchar2 in the column store. Not to make things confusing, but I just wanted to show again that you don't get a huge speed up because we're still just querying, we're having to traverse through the JSON document even in the column store. So we get a little bit of speed up, but not a huge speed up, 5.6 seconds. So a second faster, but not orders of magnitude. And then I wanted to show that same query. Notice we are going in memory, but we'll just do a normal query. So this is what you would do. You would populate JSON in the database. You would create your table with JSON in the database. You would populate that in the column store, making use of the requirements of having to set that up. And again, I should, oh, we lost. So in the JSON Developers Guide, there is a section that tells you max extended string size, all the things I showed you in the slide in PowerPoint here. So you had to do, you had to set everything up for in-memory, and then you just alter the table in memory. Whoops. Things aren't going smoothly today. There we go. And once that's populated, let's get back down to where Once that's populated, we look at that data, same query, and now it's half a second. So we went from effectively 6.5 seconds in this original query, if we were only querying the data in the Oracle database, to putting that in memory with all of the enhancements, technical enhancements to the database memory provides for JSON, and we wind up getting a half a second. So that's pretty phenomenal performance improvement. And that's the same exact query, and we see table access in memory full, and we're leveraging that information, and we know that because, remember, we've talked about in our previous sessions with in-memory expressions, these IMEUs, and we see that we are also accessing that data in in-memory expressions. Hence the reason I kind of wanted to show disabling it, just to show you where all of that speed up is really coming from. And it's coming from in-memory expressions. Then that's how we leverage JSON in the database. And we get phenomenal performance. And then I had another example.
Sorry, Andy, just to interrupt you for a second. So the stats there that show that we use the in-memory expressions is because we're querying the OSON version of the JSON documents, right? Not the C column, but the OSON version is where we're getting that benefit?
Correct. So database in memory has the smarts in Oracle database to know that if we've created our check constraint, so we have OSON data, we've enabled the ability to populate in-memory expressions because that's a prerequisite for JSON. And so as we populated the data in the column store, we populated not only the C column, which was just straight varchar2 data, which we saw wasn't particularly fast or to query. It now becomes, we're able to populate the virtual column, which is the OSON data. I know this is it's kind of convoluted, and that's what we have with database in memory. So that's where we get the speed up. So that goes back to my attempt here to show the mechanics of that. And so that's the C column. Actually, I probably should label that, make it easier. But that's our C column is JSON, which we saw we got a little bit of speed up when it was populated, because it was populated here in the column store because we populated the entire table. We didn't exclude any columns. And the OSON data was populated as a virtual column and in-memory expression. And that's what Oracle Database will just, without having to tell it, will just use if it's available. And that's where we get the phenomenal speed up in performance accessing that JSON data. Does that make sense, do you think? I mean, I'm not trying to confuse you.
Yeah. No, I just wanted you did the perfect thing. I wanted you to go back and just show me in the picture that, by placing it in memory, I got both, right? I got the C column, the standard column that I would get from any table, and I got the OSON. And if I do nothing, Oracle will use the OSON data automatically for you. I know you had that extra step just to demonstrate that the goodness isn't just coming from putting it in the column store, it's coming from the OSON. But
I always like to dive into the weeds, but not trying to confuse anybody.
But yeah, just that we're getting it from the OSON, and so I think this diagram makes that super clear. Thanks, Andy.
Yep. So we can validate that we actually use the in-memory expressions, again, with those statistics, as I pointed out. So then I did one last experiment, because what I think one of the big values of typically customers when they're querying JSON, they're actually looking for a specific a value they're querying on. Say, in my case, I put in tax amounts. But they typically don't need to scan the entire JSON document to find the specific documents they're interested in, or the subset of documents. And then they might want to go through that subset of information and get additional values. And so something like the JSON value function, which can be populated separately from the entire document, can give really fast performance. And this is especially true for our subset is pretty small, but if you're going through hundreds of gigabytes of JSON data, there's a cost to doing that if you're looking at the entire document, as opposed to what you really just need is certain portions of that document for your analytic queries to do your, what I like to call your aggregations on that data. And so the analytic portion of this then can be very valuable as well to create certain JSON values and populate those to allow you to do analytics, even though you might still at some point need to go back and look at the entire document, and maybe not. But and the point there is that it's fairly easy to do. If I go back, recall that what I had done, I want to go flying past it here. Hopefully I won't. Is that we had literally just added a column and we'd specified the JSON value. So that's what we had done to get the ability to query on tax amount. So and there's no limit. Well, there is a limit. There's a 1,000 column limit, but you can create a whole bunch of different flavors of this based on your JSON. And so it gives you the ability to be pretty flexible in what you want to query on. And then did I go flying past? I think I did. So then if we want to query on that, and again, disabled IME just to show you the difference, and it was 6 seconds again because we had to root through all of the data, even applying JSON value without the in-memory expressions, without the ability of database in-memory to do its special JSON optimizations, it's relatively slow. But when we let database in-memory do its thing, then it becomes exceedingly fast. Again, even faster than, and again, it would be better because there are customers who have very, very large JSON documents. So say if you had a 32K or a 30K JSON document as opposed to these are very big. These are they're probably like a K or less. So when you start getting very large amounts of data having to go through, this can give you a significant performance improvement and make the ability to run analytics on the JSON data very, very efficient. And so the point of this then is to show leveraging that JSON value function, and we can apply it in aggregations on top of that. Do a max, a sum, and an average, and we see that we're doing table access in memory full. We see that we're using our IMEUs again, and we get some pretty phenomenal performance. So hopefully that wasn't too confusing. I again apologize we weren't able to do that live, but kind of as a taste of how JSON can be leveraged, or database in memory can be leveraged with JSON. And again, this is all documented in the JSON Developers Guide, so you can go through your own examples if you wish. And we have a teaser of it in the in-memory guide, which points you to the JSON Developers Guide. So as long as you have Oracle Database 12.2 or higher, and you have database in memory, then you can make use of this. And one of the exciting things is that we're working currently with external tables in some of the newer releases. So you could perhaps have big data, maybe in Hadoop or HDFS. You might draw in some of this data to do some pretty phenomenal analytics. You could either do that with materialized views, so you can create a materialized views on some of this external data and populate that in the column store, because we populate tables, partitions, subpartitions, and materialized views. And in the newest releases of Oracle Database, we're allowing you to populate data from external tables directly, so you don't even have to materialize it. So we're really trying to work towards making, because Oracle Database has such great SQL facilities to actually analyze data, it makes sense to analyze that data in Oracle Database. The same tools that you use to query your relational data, you can use to query some of your external data. I don't want to say NoSQL data, but your external data. So it gives you more options. And it wouldn't be Oracle database if we didn't give you a lot of options and a lot of ability to leverage these technologies. Do we have, I guess, do you have what? So do you have anything to add to that, Maria?
No, I think you've covered pretty much all the stuff. You gazumped my external tables question. I was going to set you up for that and ask, hey, if I had Json in an external table. One of the other things that I like to use the JSON is often I'll join it to relational data, and I may even join it into relational data in a materialized view. And then populate the materialized view into the in-memory column store. So it's, you know, I always try and remind folks that you can use in-memory in conjunction with all the other performance enhancing tools that you've got in your toolbox, like partitioning and parallel execution and materialized views, and of course the rich functionality we have around JSON.
Right, yep, and that's one of the cool things about database in memory, since it is part of Oracle database, it's not separate, you do get to use all of those other features. Yeah.
All right, so the only question we had in the chat was, in your script, you're showing that you're setting an underscore parameter, but you don't show us that you unset the underscore parameter, and not to highlight it too much.
Yeah, I mean, let's face it, I'm cheating only to show a point. This is not something that you folks would ever do. If you notice that every script that I run, I always reconnect. So the reason I don't bother unsetting it is because when I run the next query down here, notice that it reconnects. So I do that in all of the scripts that we run for both Ask Tom, when I do a by example session, because typically what I'm doing is I'm showing session level statistics to show, like in this case that we're using IMEUs, and I always want to reset those. So I always start off with a fresh connection, if you will. So the reason I don't have to unset that is because I just literally connect every time. And again, I always hesitate doing tricks like this, but I thought it was valuable to understand the benefit that database in memory was providing, and I don't want you guys off setting that, but basically that's disabling the ability to use in-memory expressions. And so I should not highlight it, I should hide it, but that was the only point of doing that. And so hopefully that answers that question.
So one other question that's come in is that the OSON column isn't automatically created on the table just because it has a JSON column, but that it is on tables where the table has been marked in memory. So just so that we're clear, right at the very beginning, you had created a table with the retail table that had the C column in it, and we showed that we had a virtual column on it. Just so that people are clear, if you just create a table that's got a single column in it and you put is JSON, you don't get the, yeah, perfect. So you don't get the
it's actually it's this check constraint. Sorry, I didn't get that check constraint is what causes Oracle database under the covers to add that OSON hidden virtual column. Because notice, I don't think that's the way you said it, but so that table that I created, I literally just created a varchar2. We're not telling the database that that's well-formed JSON, we're just storing JSON in a varchar column. So Oracle's going to be less efficient in its ability to access that data because it doesn't know that it's JSON, it just thinks it's varchar2. And so once we tell the database that it is JSON, that's what actually creates that column. Because originally when we talked about this, we associated it with as a database in memory thing. And it's actually not. It's not, although database in memory leverages it, it's actually not a database in memory feature per se.
Mm-hmm. So there's several folks who are saying in the documentation that's not the case.
In the in-memory guide, it is a bug. It is but if you look at the JSON developers guide, it does talk about it. So we will get that corrected because that was between the doc writers and us as PMs, our misunderstanding of how that worked, which is kind of one of the reasons I wanted to point it out. So we'll get that corrected. Yes.
Okay, fair enough. So you're saying it's a doc bug and that you get the virtual OSON column just by adding the JSON constraint and not by adding a JSON constraint to a table that's already got the in-memory attribute.
Correct. And that's and that literally I had this conversation with the developer who corrected me. So
okay. So just out of curiosity, what version of the database are you using in your demo?
So this demo was, I think it's 18.4. Okay. But it's a 12.2 feature. So I tend to use the latest and greatest, but this all works with 12.2 and above.
Okay, cool. I think hopefully that should address Lloyd's problem. Sorry, he's cut and paste some stuff from the doc into the chat, so I'm just quickly reading that.
Well, and I understand in the in-memory guide it says that, so I'll get that back.
Okay. All right. Lloyd, if that hasn't answered your question, do let me know.
Well, yeah, please. We let's see. On the page, I believe we have our email addresses, and we certainly have our Twitter handles. So if you want, if you do want clarification, email me or message me, and I'll be more than happy to help with that.
So the next question we have is, what happens if the JSON column is a clob or a blob? In other words, longer than 32K. So
we can only populate data that's 32K or less in the column store. So it won't get populated in the column store. So I did. That was one of the other. Well, I won't bring it up. Whoops. I was going to bring it up, but we did a blog post on 32K data. So if you go to the database in memory blog, which, well, maybe I will bring it up. It's too slow to. Oh, there it was. Oh, it came back. So let's see. Sorry, I think I have I will be able to show it if I can figure out where my. It's bringing it up right now. So I did a blog post. Hopefully it'll show up here. There we go. Storing values up to 32K in size in the in-memory column store. So if you go search on that on our blog, blogs.oracle.com in-memory, and you just go search for this blog post, and I try to explain exactly that question here. What if it's larger than 32K? So if you're using a clob or a blob and it's larger than 32K, we won't be able to use that, and so it'll store it out of line, which is kind of what they say right there. So if you want clarification on that, just go Google for that blog post.
So that means the initial JSON column that I'm storing, the larger JSON documents that I'm storing in a lob or a blob column won't reside in the in-memory column store if they're greater than the standard inline size for a lob or a clob. But I can still take advantage of in-memory expressions by using the JSON value to benefit from having just the certain attributes from those JSON documents populated into the column store, though, right?
Yeah, as long as that's set. Max string size extended, right?
Yeah.
So that's a requirement.
Okay, cool. So we can still get the benefit even though we can't store the entire document. We'd need to extract certain attributes or elements out of the JSON document and have those stored in the column store and still get the benefit.
Right. And I think I explained that here, but this was back in November of 2017, so I might have to go refresh my memory. But that's the intent. The intent is data that is 32K or smaller in size, JSON data in this particular case, is the next example that I use. We can populate that column store and allow you to take advantage of it. And normally, lobs or blobs that are larger than 4K, a little bit smaller, but basically 4K, we'll store, if they're larger than that, we'll store them out of line and we won't be able to populate those in the column store. And so if they're less than that, we can, but this is kind of, I don't want to say a cheat, but an exception to the rule, if you will. And so I did try to talk about this, like I said, in this blog post. So, And I believe that's also in the, it is in the JSON Developers Guide too. It talks about that as well. That's really the place to go for this. There's a whole section on JSON in the column store and that support, and our in-memory guide just points you over to there. So that's the place to go if you want to read about it in the documentation itself.
All right. Oh, hang on. One more. Let's see. So if we extract fragments of the JSON using JSON query, making smaller JSON docs, could that be stored in the column store? And yes, as Andy said, as long as the JSON document was less than 4K, even if it was stored in a CLOB or a blob, it will be populated into the in-memory column store when the underlying table is marked for in-memory and populated into the column store.
Right.
And that's it, Andy, in terms of questions. We're getting close to the top of the hour, so I'll leave it to you to wrap up.
Oh, well, yep. Thank you all for attending. Again, I apologize for the little misstep there, but I think we got everything that I wanted to cover out there, and hopefully we answered your questions that you might have had. I don't have it up, but remember, please, that the on our Database in Memory Ask Tom Office Hours page, we have links to all of the sessions, and this will be one of them that'll be recorded and you can replay. We also have the blog that I showed you, and we have a resources page there as well. And so we have YouTube video channels. There's lots of information about database and memory. And again, and I offered it up, if you have questions, please feel free to email me. People do, and I will try to do my best to answer your question. And if I don't know the answer, we'll get one of the developers to help answer that and get your questions about database and memory answered, because again, my goal in all of this is to get folks to adopt database and memory and take advantage of what I think is really great technology.
Cool. Well, thanks folks for joining us, and we'll post the video of this session later on. We hope everybody has a good day, and we'll see you soon on Database and Memory Office Hours.
Great. Talk to you guys later.